Unit 8, Lesson 3, Representing Data Graphically. Number 1. A teacher drew a line segment that was 20 inches long on the blackboard. She asked each of her students to estimate the length of the segment and use their estimates to draw this dot plot. A. How many students were in the class? I tallied each of the dots and I got 18. There were 18 students in the class. B. Were students generally accurate in their estimates of the length of the line? Explain your reasoning. Generally, they underestimated the length. More students underestimated the length than overestimated the length. Number 2. Here are descriptions of data sets. Select all descriptions of data sets that could be graphed as dot plots. We need to look for numerical responses, such as class size, or birth weights, or the number of goals. A, D, and E answers will be represented by numerical data that can be represented by a dot plot. The answers for B and C have to do with colors or favorite sports, so those are not numerical and would not be represented by using a dot plot. Number 3. Priya recorded the number of attempts it took each of 12 of her classmates to successfully throw a ball into a basket. Make a dot plot of Priya's data. Here you can see I've drawn a dot plot with numbers 1, 2, 3, 4, and 5, and then I placed the dots above those numbers to represent the data that Priya collected. 4 people made the basket in their first attempt, 2 people made a basket on their second attempt, 2 people made a basket on their third attempt, 2 people made a basket on their fourth attempt, and 1 person made a basket on their fifth attempt. Number 4. Solve each equation. A. 9v equals 1. 9v divided by 9 equals 1 divided by 9, which is the same as v equals 1 divided by 9 or v equals 1/9. B. 1 and 37/100ths w equals 0. So 1 and 37/100ths times w equals 0. So w must equal 0 because any number times 0 equals 0. C. 1 equals 7/10 x, or 1 equals 7/10 times x. To solve for x, we need to multiply both sides by the reciprocal of 7/10. So we're going to multiply both sides by 10/7. And 1 times 10/7 equals 10/7. So x equals 10/7 or 1 3/7. D. 12 1/10 equals 12 1/10 plus y. To solve for y, we need to subtract 12 1/10 from both sides. 12 1/10 minus 12 1/10 is 0, so y equals 0. E. 3/5 plus z equals 1. To solve for z, we'll have to subtract 3/5 from both sides. And 1 minus 3/5 is the same as 5/5 minus 2/5, so z equals 2/5. Number 5. Find the quotients. A. 2/5 divided by 2. 2/5 divided by 2 is the same as 2/5 divided by 2 over 1. We need to multiply 2/5 times the reciprocal of 2 over 1. So 2/5 times 1 over 2 equals 2/10. And 2/10 could be simplified to 1/5. B. 2/5 divided by 5. That's the same as 2/5 divided by 5 over 1. And again, we need to multiply 2/5 times the reciprocal of 5 over 1, and that is 1 over 5. So 2/5 times 1/5, and that equals 2/25, or 2 over 25. C. 2 divided by 2/5. That's the same as 2 over 1 divided by 2/5. We need to multiply 2 over 1 times the reciprocal of 2/5. So 2 over 1 times 5 over 2, or 5/2, equals 10 over 2, or 10/2, which is 5. D. 5 divided by 2/5. That's the same as 5 over 1 divided by 2/5. Again, we need to multiply by the reciprocal of 2/5, which is 5/2. So 5 over 1 times 5/2 equals 25/2, or 12 1/2. Number 6, find the area of each triangle. The formula for finding the area of a triangle is half of base times height. You can imagine this triangle as a square with a base of 5 and a height of 5. 5 times 5 would be 25. The area of the square would be 25 units squared, but since the rectangle is half of the area, it's 12.5 units squared. Look at rectangle B. Again, the area of a rectangle is going to be half of its base times height. So what's half of 3 times 4? Since 3 times 4 is 12, and half of 12 is 6, the area of rectangle B is 6 units squared. Let's look at rectangle C. The base is 4 and the height is 4, so half of 4 times 4, or half of 16. Since half of 16 is 8, the area of this rectangle is 8 units squared. Congratulations! You have completed Unit 8, Lesson 3, Representing Data Graphically.